Imagine discovering a hidden flaw in a system that's been trusted for over a century. Now, picture this revelation coming from an unlikely source, a college student. This isn't the plot of a Hollywood movie, it's real life, and it just happened in the world of wind power. A groundbreaking discovery by a Penn State undergraduate has upended long-held assumptions about how wind turbines operate, potentially revolutionizing renewable energy as we know it. But here's where it gets controversial. What if the way we've been designing wind turbines all along was fundamentally incomplete? In a world increasingly focused on combating climate change, renewable energy sources like wind, solar, and hydropower have taken center stage. Among these, wind power has emerged as a particularly promising solution. It's clean, abundant, and most importantly, renewable, unlike fossil fuels, which are finite and depleting at an alarming rate. Wind is a resource that will never run out. However, while the environmental benefits of wind power are widely acknowledged, there's always room for improvement, especially when it comes to efficiency and accessibility. That's why recent advancements in wind turbine technology are so exciting. Wind farms, both onshore and offshore, have become a common sight in many parts of the world. Onshore installations are more cost-effective and easier to build, but offshore farms offer higher energy yields due to stronger and more consistent winds over water. While offshore projects come with higher upfront costs, their ability to generate more electricity makes them a worthwhile investment for governments and companies aiming to reduce carbon emissions. The challenge, however, lies in making wind power not only scalable for large-scale operations, but also accessible for individual households. Enter the innovators who are rethinking wind power on a smaller scale. Companies like SD Wind Energy are developing compact wind turbines designed specifically for residential use. These small-scale systems, often paired with solar panels, can meet the energy needs of a typical home while contributing to the global push for net zero carbon emissions by 2050. Imagine being able to generate your own electricity right in your backyard, clean, green, and independent of traditional power grids. For homeowners looking to embrace sustainability, this could be a game changer. Learn more about home wind turbines here. https www.ecoportal.net/n/home wind turbine beat solar panels 7781. But now let's circle back to that bold claim about the 100-year-old myth. Divya Tyagi, an engineering student at Penn State, has achieved what many thought impossible, solving a decades-old aerodynamic problem first identified in 1935 by British scientist Hermann Glauert. Glauert's model had long served as a cornerstone for understanding how much energy a wind turbine could theoretically produce. However, its Achilles heel was its inability to account for external forces acting on the turbine blades, such as turbulence or uneven wind patterns. Tyagi's breakthrough addresses this critical gap, offering a more sophisticated framework for optimizing wind turbine performance. I created an addendum to Glauert's problem, Tyagi explained in a Penn State news release. It determines the optimal aerodynamic performance of a wind turbine by solving for the ideal flow conditions. In simpler terms, her work provides engineers with a refined tool to design turbines that are not only more efficient, but also better equipped to handle real-world challenges. This advancement couldn't have come at a better time as the demand for clean energy solutions continues to grow. While Tyagi's discovery focuses on improving the technical side of wind power, other innovations in renewable energy are tackling a different hurdle: consumer adoption. Take solar power, for example. Despite its widespread use, one of the biggest criticisms of solar panels has been their appearance. Traditional black panels mounted on rooftops or in open fields may be functional, but they're not exactly eye-catching. Enter Solarix, a company determined to make solar power as appealing to the eye as it is to the planet. Read more about their innovative designs here. https://www.ecoportal.net/n/goodbye black solar panels new design 11481. Solarix's panels are designed to blend seamlessly into building walls, rather than standing out as bulky additions. Available in 16 colors and over 76 unique designs, these panels prove that functionality and aesthetics can go hand in hand. This shift highlights an important truth. Sometimes encouraging people to adopt sustainable technologies isn't just about improving efficiency. It's about making those technologies desirable. So, what does all of this mean for the future of renewable energy? Will Tyagi's breakthrough lead to a new generation of super-efficient wind turbines? And can innovations like Solarix's colorful panels convince even the most skeptical consumers to embrace clean energy? These questions remain open for debate, and we'd love to hear your thoughts. Do you think these advancements will accelerate our transition to a greener future? Or are there still barriers we haven't addressed? Share your opinions in the comments below.